Okay, good morning, everyone.
Good morning, sir.
Okay, so just to recall what we have discussed in our previous session, we have discussed a few of the terminologies regarding the operational research as well as the optimization technique. We have also discussed, along with the terminologies, what are the steps that are required to be taken as a proper operational research. So, just to recall those steps, let me just share the screen. So I hope the screen will now be visible to you all. Okay, so these are the roles of the operational research specialist. So, for example, there any of the organization, as I told that few of the good organizations are having a specialized team of operational research, and they are called as the operational research specialists. So, depending on the organizations, there would be certain issues that the employees will be facing, and even the organization will be facing with some of the issues like like the loss the organization could have undergone through a severe loss, or there is no much hike in the profit, and there are all the different types of the issues that the organization may face. So this is the role of the manager, that they need to recognize what are the issues that the organization is facing, what is the main problem. So the manager then decides or discuss with the operation research specialist team that this is the particular issue which the organization is facing, and they collectively decide what are the probable factors that will be leading to this particular issue. And depending on the factors, they would be having the relationships like this particular factor is having the highest most impact over the organization's problem, or this particular factor doesn't contribute much towards the organization's problem. And then the operation research specialist team investigates the methods that have been adopted in the organization, and they just decides that okay, this is the particular method which is having the issue. Then the organization deals with these particular issues, and the operation research specialist again tries to find the solution to this particular problem. They would be having a certain set of the solutions. They won't be saying that okay, this is the only solution you should be using. No, they would be having the certain steps or the certain set of the solutions. Now, why I am saying that they won't be proposing only a single solution while they would be proposing multiple solutions, because they are the team who are working from outside the organization, and the manager better knows that what is the organization is actually trying to do. So the specialist team may always not suggest the best possible solution. So the manager comes into the role once the operational research specialist team decides that okay, these are the probable solutions that can be that can come handy in solving this particular problem. So he decides or and discuss with the manager that these are the particular solutions. Now it's on you to choose which is the best possible solution, and the manager looks into the constraints. That okay, just for the example, if the employees are facing the issues with the salary that they are receiving, so the operational research specialist says that okay, with the work that you are giving, the salary of this particular employee should be now 10,000 more than what you are actually giving. So the manager says that okay, let me look into the budget of the company so that I can increase by some of the percentage. And then the manager says that okay, I depending on the budget of the company, I may not be able to hike the salary by 10,000 rupees, but I can certainly hike the salary by 6,000 rupees. So this is what the manager decides depending on the organization's perspective, practical constraints. The organization there would be certain constraints also in the organization. So the manager says that okay, this would be the best possible solution, and collectively the Manager says that okay, I will be choosing this particular solution, and now there's all the money that the operation research specialist required for selling his idea and for making the organization into the benefit or giving the organization a profit. So this is what that exists, a mutual cooperation and understanding in between the manager and the operation research specialist. So this is how the entire operation research team deals with. So now coming back to the examples where this type of things can come into handy. So these are a few of the examples like rescheduling the aircrafts. There are the chances that because of the environmental issues, there can be the delay or the grounding stops that may cause the delay. So there are the frequent reschedulings in the aircrafts. So at that time, the operation research team comes into the picture who will be saying that, okay, this is not the perfect planning. So you need to replan it in this certain manner. Then one of the questions that was asked in the first lecture that can this be used in the electronics type of domain? Yes. So you can see in the second point that is the planning production for the PCB assembling. So this is where your OR is used. Then the another things like the machine productions, like sales forecasting, timetable management. Also in the timetable also, this entire thing of OR can be used. How in the timetable management, there will be the constraints of the faculty hours. There can be the constraints of your timings. There can be constraints of the accommodation in a particular classroom. There can be the constraints of accommodation in the lab. You can observe then you are not always getting the lab in the second slot. It's not like that that you will be getting the lab in the second slots only. No, depending on the different practical constraints, you can have the schedulings of your courses. Then in the advertisements, you are having this OR, and in the promotion of any of the employee or selection of the employee in a company also requires the strong knowledge of operations research. So these are the all the scopes that we have already discussed in the finance, in the purchasing, in the production, marketing, in the personal management, then in the research development, and all the budgeting, defense, agriculture, education, transportation. In every field, you require the OR team. They would be helping the organization to have the better management of all the things. So this is the scope of OR. And with this thing, we just end our theoretical part of the first module, that is the introduction to operations research. Now, moving to the next part, moving to the next part. Okay, I got one question from Viraj. Sir, why don't we see such recruiting here? Um, okay, I didn't actually get your question. Can you just elaborate on the question, Viraj? If you can unmute your mic and say.
Yes, yes, sir. I'm asking that, like you said, that OR specialist is here. So, like, from the last two past years, I'm seeing that we don't recruit here such type of a space in such companies here in India. So, like, why so?
Okay, the reason behind is that see the team of OR is very experienced. They don't always say haphazard solutions. So in any of the smaller companies, if you just look into any of the smaller companies of let's say Rajkot or Ahmedabad or any of the cities, then in the smaller companies, the OR specialists now will be charging too much of the cost for just your idea. If you have just gone through the proverb that your idea matters a lot, and selling your idea will be giving you the higher profit. So this OR team is quite experienced, and they are charging too much of the money. And plus, they are there to always help. But what is the issue with this particular smaller organizations is that they are not able to afford the money, and secondly, there are the chances that the manager don't want to include any external authorities who will be playing the role of suggesting something. Because in India, we generally see, or not in India, I would be saying, but in many of the places, we generally see that we don't always follow the suggestions. So whatever, but let me make this thing clear that whatever the OR specialist team is saying is the very, very useful suggestion. And there are the chances that there can be the conflicts in between the managers and the team, specialist team. So these are all the things that the manager looks into, and the manager himself then says that, okay, I am taking the responsibility of OR. Whatever I will be facing the issues, I will be solving it by myself. So this is what is been done in small scale companies. Okay, so let's start with the new module. I won't be saying the entire module, but let's start with the mathematical development of the models. So if you can just look into this thing, mathematical modeling. So in the very first lecture, I have told that we will be dealing with the mathematical models. And if you are quite familiar with the mathematical modeling, like in the case of, if you are quite um, extensive enough good in the mathematical modeling, then you will be having a better chance of solving all the problems. So that is the reason I will be giving you intense learning about this particular mathematical modeling stuffs. So I would be now requesting everybody to just have a note and the pen with you so that we can have the solution of all the questions and we can develop the mathematical modeling. Okay. So what are the guidelines specifically for development of the model? So these are all the theoretical things again, which you will be understanding once we develop a particular mathematical model towards a particular question. So this is the main guideline that you need to first of all identify the decision variables. That means for a given problem statement or for a given use case, you need to identify which are the particular variables that are creating the huge impact, the impacting variables, or for the maximization or the minimization or in any of the constraints, you need to identify which are the major playing role playing variables. And along with that, you need to identify what is the problem data that has been given, what is the data that has been given to you. So after having identification of the variables and the data, we would be making a mathematical model or in the form of the tabulation. So we would be making a mathematical tabular model, and then we would be formulating our objective function. Now this particular objective function is the function of either maximization or either minimization. So this is what we are going to deal with. We are going to deal with either maximization or minimization. And along with this, there would be certain constraints. So for example, if I can just say that you need to earn the profit for your company. So let's say your company is saying you, suppose you are the sales manager or the marketing manager, and the company says you that you need to sell these products such that you get the profit of 10% over the products, such that over your profit will be 10 percentage that you need to earn for the company. So your ideal situation will be to maximize the profit. Your ideal situation will be to maximize the profit. Along with this, the company will be also giving you the target. This target will be in terms of the number of days. That means you need to maximize your sale. You need to earn 10% of the profit in the next 1 month. So time duration is 1 month. They won't be saying you that as per your own wish, you can earn the profit, but I want 10% of the profit. They won't be saying you that you can take 1 day or you can take the scale of, let's say, 100 days, or you can take the scale of, let's say, 1 year, 2 year, 3 years. No, they will be giving you the fixed target goals that at the end of the first month, your selling should be this one and the company should be getting the profit of 10%. That's it. They won't be saying that, okay, whenever you earn the profit of 10%, at that time you can report me. No, they won't be saying that. They need a particular profit corresponding to a particular time frame. So this is nothing but dealing as the constraint. Constraint. In this case, the constraint is the time, where they have provided you the time of 1 month. So this is the main thing that you need to identify while modeling. while developing the mathematical model or while formulating the mathematical model. Okay, you will be better understanding this once we discuss few of the examples. So let's start doing this particular example. This was the example that we have already seen in the first session. While one of the person has raised the question that what we actually mean by the mathematical model. So I have just shown you this particular question, and we have discussed about this question. So now let's start with this particular question only, and let's try to develop the mathematical model corresponding to this question. So I will be requesting everyone to just spend time to just read this particular question and understand what the question is trying to say. And I will be asking you what the question is trying to say. I'm not saying you that you may develop the mathematical model. You won't be able to develop as is the first example, but at least try to understand what the question is trying to say. Okay, isn't the question visible? I guess so. Okay, can you please tell whether it is visible? Okay, fine. Okay, so can anybody just volunteer? Okay, Akshat has given the correct answer. Fine. So, okay, can anybody just volunteer to explain what this particular question is trying to say? Anyone who can just tell what this question trying to say? Very simple question.
Hello, sir.
Yes.
Sir, this question is trying to say that there's a chocolate manufacturing company that produces two types of chocolate, that is type A and B. And for making the chocolate of type A, it requires 1 unit of milk and 3 units of cocoa. And likewise for B, it is 1 unit of milk and 2 units of cocoa. Now it is given that company has limited resources, that is 5 units of milk and 12 units of cocoa, and the company is willing to make maximum profit. And the cost price of the selling price of type A chocolate is 6 rupees, and that of B is 5 rupees. So it is asking, in order to maximize the profit of the company by selling these chocolates, how many pieces of each of these chocolates should be sold in order to make the maximum profit?
Okay, fine, correct. So let me just take this particular part onto whiteboard and let me just explain it in detail how we can go for the mathematical modeling. So let me just share the whiteboard screen. I've just taken the screenshot of the entire question. Okay, so this is the question that you can see on your screen. I've just taken the screenshot, so you will be seeing the zoom bar and all the things. Right. Yes, Zil, correct. You can solve this by the linear equations, correct. So basically, if you can recall the entire question, then let me just read the entire question again. So there is a company which is trying to manufacture two types of chocolates, that is type A and type B. Type A and type B. Now, for the company, let me write over here type A and type B. There are the two types of the chocolates that a company is manufacturing. And now it is given that each unit of A requires 1 unit of milk and 3 units of choco. So in this particular case, these are the things that are been nothing but the products. They are nothing but the products. They are nothing but the products. So let me say that in order to manufacture the products, the resources are nothing but the milk and the choco. Milk and the choco are the resources, so they are nothing but the resources, or you can say the ingredients. In this particular case of optimization, we would be considering them to be the resources, because without these resources, we won't be able to manufacture the chocolate. So what has been given that for each unit, so I'm writing that for each unit, I'm writing over here for each unit, for each unit. So for each unit of A and for each unit of B, the milk unit I would be requiring 1 unit of milk I would be requiring, and 3 units of choco I would be requiring. So in this particular case, if you just recall what we have been given as a steps to solve the mathematical model, then we were been given that identify the main problem definition. So in this particular case, I have identified the main problem definition that, okay, my problem definition is nothing but the company is manufacturing A and B types of the chocolate, and at that particular time, the resources are nothing but milk and choco. So these are nothing but my decision variables, because they would be playing the major role as a part of the resources. So they are nothing by my decision variables. Okay, now I'm further reading the question that each unit of B requires 1 unit of milk. So I will be writing over here 1 and 2 units of choco. So if you can just recall again, this is the tabular formulation. Tabular formulation. Okay, I have read the question till this part. I read the half of the question, the top half of the question. Now I am reading the latter phase. Company has total 5 units of milk and 12 units of chocolate. So this is nothing but again my limitation. So I will be writing the availability. Availability. I will be writing over here the availability. The availability is nothing but the total 5 units of milk. So this is nothing but 5 units of milk is available with the company. And 12 units of the choco is available with the company. Next thing that has been given, that on sale company makes the profit of this much. So the company makes the profit of ₹6 per unit and 5 per unit on type B. So now my next parameter is the profit. Profit. It is saying that 6 on A and 5 on B. Now this profit is what my main intention is. So what is being given in order to maximize the profit, that means my main intention is to maximize the profit. So this is my what objective is. This is what my objective is. What I need to determine how many units of A and of B should be produced. How many units of A and B should be produced? So let's say I am just in terms of the aptitude. This is nothing but your aptitude question only. So let's say I'm writing over here, let x1 units of A are produced. So what you used to do in your aptitude, you just suppose that let x1 to be this one, let x2 to be this one. So whatever your main question is, you just suppose. So same thing, let x2 units of B are produced. So I'm just supposing that, okay, let x1 units of A are produced and let x2 units of B are produced. So I'm just writing over here for simplicity x1 and x2. Now, in my mathematical model, in my mathematical formulation, what is my objective function? The first step will be to objective function. What will be my objective function? Correct, Zil? Okay. My objective function
Sir,
is, yes,
total profit.
right. My objective function is the profit. So the profit is nothing but maximization. So it will be my maximization cost. That is to maximize what we need to maximize profit. How we can define the profit? The profit can be defined as this one, 6 rupees on A. If you can just recall the question that has been given, rupees 6 per unit of type A, rupees 6 per unit, it's nothing but per unit. So if I am selling x1 units, if I'm selling x1 units, then the profit will be 6x1. If I am selling x2 units of B, then my profit will be 5x2. And this both will be contributing to my profit. So my objective will be to maximize the profit. That is max 6x1 plus 5x2. This is my objective function. This is my objective function. Along with the objective function, I am being given the constraints. So I need to maximize the profit subject to constraints. Which are the constraints that have been given to me? The availability. The availability always plays the role of the constraint. So this availability, let's say if I am manufacturing 1 unit of A, then I will be having 1 unit of milk that will be utilized. If I'm manufacturing 1 unit of B, then 1 unit of milk will be utilized. If I'm manufacturing 2 units of A, then 2 units of milk will be utilized. If I'm manufacturing 3 units of B, then 3 units of milk will be utilized. So if I am manufacturing x1 units of A, then 1 into x1 units of milk will be utilized. So constraint for the milk, let me write the constraints for the milk. So it will be x1 units of the milk will be utilized. My total availability is 5. Total availability is 5. So that means along with this, I will be also manufacturing B. So if I'm manufacturing x2 units of milk, then my x2 units of the milk will be utilized. This summation should be less or equal to 5 because it is the maximum value that is available with me. That means x1 plus x2 is less or equal to 5. This is just for the milk.
Excuse me, sir.
This is just for the
Excuse me,
milk.
sir.
Yes, Jyoti, any doubt?
Could you please repeat how you came up with that X1 plus X2? I don't
I
understand.
didn't get, can you repeat again?
Could you please repeat how you came up with the equation for the milk?
Okay, so you are asking for this constraint equation or objective function?
That one, the one for milk. That one.
The constraint one.
Yes, the X1 plus X2 is less than 5.
Okay, so let's say my intention, my main availability of the milk is 5 units, right? I am being given that, okay, for each unit of A, I will be requiring 1 unit of milk. And for each unit of B, I will be requiring 1 unit of milk. So this is what I have been given. This is for the milk. Now, if I am saying that I will be manufacturing 2 units of A, then I would be requiring 2 units of the milk. If I'm saying that I will be manufacturing 3 units of B, then I will be requiring 3 units of milk. If I'm saying that I will be manufacturing 4 units of A, then I will be requiring 4 units of milk. So similarly, if I'm saying that I will be requiring, I would be manufacturing X1 units of A, then I will be requiring X1 units of the milk. Same thing, if I'm saying that I will be manufacturing X2 units of B, then I will be requiring X2 units of the milk. My total availability is 5. My total availability is 5. So that means whatever maximum I am having, I cannot utilize or I cannot have the production of 3 units of A and 3 units of B because I don't have that much milk. So I can only manufacture until and unless my availability is satisfied. So that means this both the summation should be less or equal to 5. Because if I'm manufacturing 3 units of A and 3 units of B, then it will be 3 plus 3, 6 units of the milk that will be required. But the company is having only 5 units of milk. So that is the reason I cannot manufacture that. So I will be writing that, okay, X1 plus X2 must be less or equal to 5. Same case for Choco. Same case for Choco. For the Choco, I have been given, let's say, if I am writing over here again in the same format, that for A, for each unit of A, that is for 1 unit of A, I am requiring 3 units of Choco. And for 1 unit of B, I will be requiring 2 units of Choco. So likewise, if I say that, okay, I will be manufacturing 2 units of A, then I will be requiring 6 units of the Choco. This is for the Choco. If I'm saying that I will be manufacturing 3 units of A, then I will be requiring 9 units of the Choco. If I'm saying that, okay, I will be manufacturing 3 units of B, then I will be requiring 6 units of the Choco. Same, I am saying that, okay, I will be manufacturing 4 units of B, then I will be requiring 8 units of the Choco. Likewise, if I'm saying that I will be manufacturing X1 units of A, then I will be requiring 3 into X1 units of the Choco. Because 1 unit requires 3 units of the Choco. So X1 units will require 3 X1 units of the Choco. And likewise, I am saying that, okay, X2 units of the B, if I am manufacturing, then I will be requiring 2 X2 units of the Choco. And this total units of the Choco that I will be requiring, this is the nothing but the Choco units. This total units of the Choco, maximum I am having 12 units. That is the availability. So the summation of this thing must be less or equal to 12. The summation of this must be less or equal to 12. So that means my another constraint is nothing but 3x1 plus 2x2 must be less or equal to 12. Anybody having any doubt in any of this thing, either the objective function or the constraints? This is the only thing you are required to do. This is the only thing you are required to do in building the mathematical model. Kindly acknowledge in the chat box, or you can just unmute your mic and say, because I want everybody to get clear with this. I will also take the exam for the development of the mathematical model after 3 to 4 sessions, or after 2 to 3 sessions, whenever I will be satisfied that I have given you ample amount of the practice for this mathematical modeling. Okay, fine. So these are both the things where you require x1 and x2. These are the things where you require this type of functional things are there. These are the functional things that you are having. So these are called as the functional constraints. These are called as the functional constraints. Along with this, the constraints which we need to specify is the non-zero constraint, which is very important. Why? Because the x1 and x2 are nothing but the number of units. X1 and x2 are nothing but the number of units. And this number of units cannot be less than zero, cannot be less than zero. So what I will be mentioning, x1 and x2 must be greater or equal to zero. This is the complete solution of the mathematical modeling. If you are missing out any of this step, the first one is the objective function, the second one is the functional constraint, the third one is the non-zero constraint, then it is not called as a complete mathematical model. So if I am asking you, I'm giving you this particular question and I'm asking you to develop the mathematical model, then your answer will be this first, the tabulation, the format that you need to do. Then this particular assumptions. Now over here, the decision variables. The decision variables, these are all the resources that have been given. The decision variables are x1 and x2. The decision variables are x1 and x2. That means they are deciding your profit. They are deciding your constraints. So they are called as the decisional variables. And this is your objective function. This is your constraint. In constraints, you will be having two types of constraints. The first is the functional constraint. Second is the non-zero constraint. So this is what has been expected from you while designing any mathematical model. Okay, so let's move forward to the next example. But before moving to the example, let me just slide through few of the theoretical part. So I hope the screen will be visible. So this is what we have done. This is what we have done. We have written over here, the profit must be the maximum. Maximization, they have just given the variable name, that is, let's say maximization of x equal to 6x plus 5y. This is nothing but the equations, the constraints. And this is the non-zero constraint. Now, as of now, we would be attempting to find the solution for this thing. We would be attempting to find the solution, but as of now, we won't be dealing with the solutions. We will be dealing with the solution of all these questions later on once we learn how to find the solution using certain equations. So now one of the answer, I guess, that was been given was we can use this using the linear equation solution. And yes, definitely you can do this using the linear equation solution. We will also learn few of the other methods that are helpful in finding the solutions. There are also different limitations of linear equations, which we will be exploring. Okay. Further moving forward, so this was the type of the linear programming or the model tabulation that we have developed, and this was what our main objective function is. Either you maximize or minimize, and the constraints. So this I haven't shown you prior, because if I would have shown you, then you would definitely just lose your interest from this particular case. Okay, so what are the assumptions while dealing with this type of functions? This is nothing but the linear programming. Why we are saying it to be the linear programming? This is the first step of linear programming. Although the name considers programming, it is not the programming. Programming is given because we are ultimately trying to find the solution, and in the programs you find the solution. That was the reason it is being told as the programming. But why linear? Can anybody tell me why linear? Why it is called as a linear programming?
Sir, I think because the power of the decision variable is 1, so it is called linear.
Right, correct. So in any of the equation, if you just observe, your power or the degree of the polynomial is 1. And in the linear problems, you are having the degree of the polynomial to be 1. And that is the reason it is called as the linear programming. Okay. So which are the assumptions? Which are the assumptions? So first is the certainty. Certainty is a very huge assumption that we are doing in this linear programming. Certainty is nothing but all the parameters and quality of the resource data are known. We are knowing that a particular unit of the chocolate will require 1 unit of milk and 3 units of the choco. So this is what we know. So we are knowing all the things. We are knowing, we are having the data corresponding to all the parameters. We are having the data corresponding to all the resources. So this is what is may not be possible in the real life scenarios, that you may not be able to know that what resources you are having or how much resources you are having. Fine, you may not be able to know how much resources you are having. So this is what is the major limitation of this linear programming. Another thing is additivity. Additivity. If you will just recall the example that we have discussed, the value of the objective function and the total amount must be equal to the sum of the respective individual contributions. So if you can just look for this particular thing, wastage or residue. So it assumes whatever assumption we have done. If you can just recall the example that we have discussed, that there is no wastage. And in the industry, in the production house, there would be some wastage. There would be some wastage. But in this particular case, we have assumed that, okay, there is no wastage. Why there is no wastage? Because we have assumed that, okay, whatever resources were there, we have utilized those resources. Then we will be utilizing those resources to the fullest. So that is the reason we are assuming that, okay, the production is not having any of the wastage or residue, which is not in the practical case, because in the industry, you will be having lots and lots of the wastages. There are the chances that while manufacturing, some of the particles of the chocos gets scattered from the machine. So we are not taking that thing into account over here. Another is the linearity. So it says that if the production of 1 unit uses 5 hours of a particular resource, then making 3 units will be using 15 hours only. Then in the 3 units, it will be using 15 hours only. But there are the cases that the bulk production may result into the faster production. That means, for example, if you take the example of the cement industry, or cement production, you would have learned this in your schooling days, that in the cement production, in the production house, you will be requiring 3 days to just reach to the temperature. So in that particular case, if you are saying that, okay, I am manufacturing 1 kg of the cement in 3 days, because you would be required to reach that particular temperature. So it doesn't mean that for all the production of the 1 kgs, you will be requiring to heat up that particular production or production device. No, it is the single time heating that you need to carry out. So for that thing, this is the major, again, assumption that if you are saying that, okay, I could produce this 1 kg of the cement in the 3 days. So that means it assumes that, okay, if you are producing the cement in the, let's say, if you want to produce the cement of 3 kg, then it will require 9 days. But that's not the case. There can be the chance that you can get the production of the second and the third kg of the cement in within 5 minutes, because the particular device is already heated up. So this is the another assumption. The next assumption is that while solving this particular equations, you would have just recalled your typical mathematical solution problems using the linear equation solution. There were some canonical forms. So if you just recall those things, then you will be realizing that not always our answer can be a whole number, or not always our answer can be integers. We are not assured to get the answers as our integer values. So we may get the decimal values as our answer. We may get the decimal values as our answer. Now, if the question is like how many men will be required to produce this particular thing, or how many men will be required to just have farming, then at that particular case, you can say that if you are solving the equations, then you will be getting 2.53 men. Let's say 2.53 men or 2.53 workers. Then how can I divide a person into a half? It's not possible. So that is the another limitation, that it considers that all the things can be divided into half and they are divisible. So that is the reason it will be giving you the answer as 2.53. So you need to then convert it into 2.0 or 2, because you can't divide a person into half. So this is what they are, the assumptions that we have taken in the linear programming. These are all the assumptions that we will be dealing with. So in some of the cases, if you are getting the answer as, let's say the industry is producing 2.5 machines, 2.5 machines, then you need to convert it to the 2 machine, the lower bound, 2 machine, because 2.5 machine, that means the half machine manufacturing doesn't take place. So this is what is to be considered over here. Okay, I hope the assumptions will be clear. So what are the advantages of this particular programming? So it is quite easy. It is quite easy to deal with, and it helps in the decision making. That okay, if I just assume all these things, then if someone asks me that now what is the maximum profit I can get, then I can readily say that okay, using this type of things, I can get the profit of x or x plus 1 or x plus 2 or anything. So it is easy in the decision making, plus it is quite effective way of determining the resources and the profit. Secondly, it improves the quality of the decisions. That means using this type of thing, using this type of the production, I can have the quality of the decision. That okay, let's say instead of the 2 units of the choco, if I manufacture 3 units of the choco, and instead of 2 and 3, this is for the A and this is for the B. If I just manufacture 3 units of A and 2 units of B, then also my purpose will be served. And in this particular case, I will be getting more profit. I can just take the decision like this one. I can take the decision like this one. So it helps to take the decisions effectively. It improves the quality of the decisions. That will be resulting into the optimal solution. That will be helping into designing the optimal solution. Now, these are the advantages of linear programming. What are the limitations? Whenever there will be the advantages, there will be the limitations always. So what are the limitations? So the limitation is that it assumes the linear relationship among the decision variables. That means if you are having x1 and x2 with the reference to the availability, if you are saying that, okay, if I would be manufacturing 1 unit of x1 extra, then it will be saying that, okay, then you need to reduce the 1 unit of x2 also. So it assumes the linear relationship. Plus, it doesn't take into account the discounts of the bulk purchase. So if you are saying that, okay, I am purchasing 1 kg of the apple and I am getting the profit of 2 rupees, then it will be said that, okay, if you are purchasing 5 units of apple, then you will be getting the profit of 10 rupees. It doesn't consider that, okay, there can be the discounts in the bulk purchase. That okay, in 1 kg of apple is giving me the profit of 2 rupees, then there are the chances that in the 5 kg of the apple, I will be getting the benefit of 12 rupees. So it doesn't deal with the discounts, which in the real life, we are dealing with. We are used to say, if you just recall, now we used to say that, okay, if a particular product is, let's say, of 10 rupees, then you used to say that, okay, give me 3 products of 25 rupees or give me 3 products of 20 rupees. There are the bargainings, right? So we usually don't consider that thing in the linear programming. The another thing that we are having over here is there is no guarantee that the decision variables will get the integer value. So this is what we have discussed, that if you are having the workers, then you can get the solution as 2.5 workers. So there is no guarantee to get the integer value. So you have to convert it into the integer value or round up to the nearest possible solution. It doesn't take into account the effect of time and uncertainty. Why time and uncertainty? So if you are saying that, okay, my farm is producing 1 kg of the potato, or my farm is producing 1 kg of the brinjal, then it doesn't take into the account the uncertain situations like the cyclone that has recently came. So it doesn't take into the account that okay, if there is a cyclone which is the uncertain situation, then my farm won't gets damaged. So it doesn't take into that consideration. So we usually don't take into the consideration the effects of the uncertainty while dealing with the linear programming. Parameters like parameters, these are all the parameters which are assumed to be the constant. So we usually don't consider the parameters to be variables. We usually consider that they are the constant parameters. For example, we are always considering over here that okay, 1 unit of the milk will be taken by all the chocolates. But there are the chances that if you just consider the bulk production, then there are the chances that instead of 1 milk, there could be the 0.998 milk also. If you even have experienced this thing while purchasing any gold thing, then you if you just purchase two or three bangles together of the same shape and of the same pattern and all these things, then all these bangles will be having different weights. You can't have the same weight for all the bangles irrespective of them to be of the same size, same shape, or the shape will definitely be the same but same pattern. So this is what you usually have in your practical life, that all the three bangles won't be having the same weight, but in linear programming it considers that they are having the same weight. In linear programming we usually deal with only a single objective function, that is our only objective function. Like in the manufacturing of the choco or in the chocolates, we haven't considered that okay, there would be the case of the electricity power that will be utilized. So our intention is also to minimize the electricity power. So along with the profit maximization, my um, other objective function is also to minimize the power consumption. So I usually don't consider the multiple objective functions, which in the real life scenario, you will be dealing with the multiple objective functions. So this is what we have seen, the assumptions, the advantages and the limitations of the linear programming. So in tomorrow's session, we will be dealing with a few of the other examples. So get ready for the examples, and we would be starting to learn the development of the mathematical model. I would be strongly recommending you that you can at least spare half hour or 45 minutes for practice of the development of the mathematical model from the J.K. Sharma book. I already uploaded this book in the Canvas. You can spare time. You can just open the module of linear programming. You can just look into the mathematical development. You can pick up any of the method. Don't try to solve the equations, but at least try to understand the questions and develop the mathematical model, because the mathematical model plays the quite crucial role in all this particular solution. So you need to have extensive practice of the mathematical model development. So that's it from today's session. So just write your roll number and name in the chat box for the attendance. And if you are having any query in today's session, then you can ask. I will be definitely, I'm saying that after 2 days, I guess I will be satisfied with the practice that you will be getting for the mathematical development. So after that, I will be taking your exam corresponding to only mathematical model development. So that is the reason I'm saying you start practicing the development of the mathematical models. You start understanding the formulation. You start understanding what the question is trying to say. So that's it. Thank you, everyone. And if you are having any questions, then you can ask.
હેલો સર.
યસ.
સર આમાં એટલી બધી આપણે લિમિટેશન હે તો એ ઘણી મેથડ બીજી આપણે ફાઇન્ડ ન કરી શકીએ કે જેનાથી આપણે પ્રોપર સોલ્યુશન મળી શકે.
હા, આમાં ઘણી બધી મેથડ્સ છે. તમે લોકો મેથેમેટિક્સમાં કરતા હશો લિનિયર ઇક્વેશન સોલ્યુશન માટેની મેથડ. તો
હા
એમાં
સર,
એ લોકોને
એલિમિનેશન ની બધી.
હા, એલિમિનેશન ને બધું. તો રિયલ લાઈફમાં 2 થી 3 પેરામીટર્સ જ ન હોય. તમે લોકો અત્યાર સુધીમાં 2 કે 3 વેરિયેબલ્સનું જ પ્રેક્ટિસ કરી હશે. XYZ કે X1 X2 X3 એવી રીતના. રિયલ લાઈફમાં ઘણા બધા ફીચર્સ હોય. તો જેમ જેમ ફીચર્સ વધતા જાય એમ કોમ્પ્લિકેટેડ થતું જાય. તો એના માટે બીજી મેથડ્સ છે. તો આપણે આમાં લિનિયર ઇક્વેશન તો તમે ઓલરેડી કરેલી છે. તો આપણે આમાં ગ્રાફિકલ મેથડ કરશું ને સિમ્પ્લેક્સ મેથડ કરશું. એટલે ઘણી બધી એવી મેથડ્સ છે કે જેનાથી આ સોલ્વ થઈ શકે.
ઓકે ઓકે સર, થેન્ક યુ.
ઓકે.